These are the lesson 2.3 notes on subtracting rational numbers. And like adding rational numbers, to subtract, use the same rules for signs as you used for integers. In example 1, we are subtracting fractions. So my first step, the same as when I'm handling integers, is to change the subtraction to addition, and I'm going to add the opposite. So let's start with that. So I'm going to have negative 4 and 1/7. I'm going to change the subtraction to addition, and then the opposite of negative 6/14 is positive 6/14. And then I decide whether I'm going to add or subtract. My signs are different, so I'm going to subtract. And then I look at those problems and recognize that I have different denominators, so I need to find a common denominator. 7ths and 14ths will both go into 14ths, so let's use that. 7 goes into 14 2 times, and 2 times 1 is 2. 1/7 is equal to 2/14, and 6/14. And now I need to subtract those. If I've got 2/14 and I need to subtract 6/14, I'm going to have to borrow. So I'm going to make this 3 and 16/14. I borrowed one whole. The whole that I borrowed is 14/14, and then I add 2 more 14ths, so I've got 16/14. I wonder if it, anyway, all right. So now I've got 16/14. Did it again. Minus 6/14 is 10/14. I've got negative 3 and 10/14. And I need to simplify that by dividing the numerator and denominator both by 2. So I've got negative 3 and 7/14. Right. I know that some of you like to change this into an improper fraction by multiplying. Here, you would have gone 4 times 14, and then you would have added on 2, and then you would have had a big number that is still okay, but I think that it makes a simpler problem if you just borrow one whole instead of making that whole thing into an improper fraction. All right, looks like your U tries are pretty straightforward. Example 2 is subtracting decimals, which is, of course, always easier than fractions. Again, we change the subtraction to adding the opposite, plus negative 21.6. I have a positive and a negative, so I need to subtract and use the sign of the bigger number. So I'm going to put the greater absolute value on top, 21.6, and subtract 12.8. We'll line up the decimals. 16 minus 8 is 8. Down my decimal. 10 minus 2 is 8. And then because my negative number was bigger, I keep my answer should be negative. And I always like to double check. 8 and 8 is 16. Carry the 1, 9, 10, 11. There's the 1. Carry the 1. Okay, so that's right. And again, I think those are pretty straightforward. there's some nice understandings here in example 3. When we're finding distances between two numbers, this example is on a number line, but anytime you are finding distances or the distances between the numbers, we're finding the difference. And when you're finding the difference between two numbers, that tells you that you're going to subtract. So if I want to find the distance between these two numbers, I'm going to subtract them. And we're actually going to do it both ways so that you can see that you get the same answer. So we're going to do 2 1/3 minus -2 2/3. So finding the difference between them. And then we'll do it again, and we'll start with this one. And we'll go with -2 2/3 minus 2 1/3. So we'll try going from here, take this one, subtract this one, or then we'll go from here and subtract this one and see what happens. I'm going to keep my first number the same, change subtraction into addition, and then change the next sign. If you want to think, keep, change, flip, that is okay. I check and see that I've got a common denominator. So now I've got 2 1/3 plus 2 2/3. I have common denominators and they are both positive numbers, so I can just add. And I have 4 3/3, which is equal to +5. On this side, oh, that's interesting. I didn't get the same answer. I got to think about that. Oh, I know what's going on here. Okay, never mind. So I'm going to change that to addition and -2 1/3. And then again, I've got the same denominator and they're both negative, so I can just add them together. So I have 4 3/3. This time it's negative, so that's going to equal -5. But since I'm just looking at the distance between the two numbers, I actually want the absolute value. Distance is positive, so I want the absolute value. Sometimes they'll give you a problem and they will tell you where to start. Like maybe somebody's on a diving board and they plunge down into the water, and then you have to find the difference between their starting point and their ending point. I'll just write a note on there. So we're going to subtract the start point from the end point. So in this problem, it didn't matter because they just said to find the distance between the two numbers, and they didn't tell us which one to start with. But if you have a problem like a diving board or a fish is under the water and it's leaping out, they will tell you which one to start with. So be sure that you take the end and subtract the beginning, because sometimes the sign will matter. This one's going to be a little, oh, not this one. This one's fine. It's the next one. All right. Now we have our real life application. So in the water, the bottom of a boat is 2.1 feet below the surface, and the top of the boat is 8.7 feet above it. Towed on a maybe we should draw. Here's the water, and here's the boat. All right. And so the bottom, that distance, I guess I could have made it bigger, is 2.1 feet. And then this distance is 8.7 feet. This is a great example of what I was just talking about. And then towed on a trailer, the bottom of a boat. So now we're going to add the boat onto a trailer. Dare I try to draw a picture? Here's the trailer. And now we're going to put the boat on top of that. All right. And now the bottom of the boat is 1.3 feet above the ground. Also, not to scale. So we want to know if the boat and the trailer can pass under this bridge, which has a clearance of 11 feet 8 inches. Notice that as I'm reading the problem, I'm sketching a picture so I can kind of visualize what's going on here. I can see from my picture that if I want to find the height of the boat, that I can just add those two numbers together. But if we want to show the difference between these two things, we go from 8.7. From 8.7 down to 2.1. I'm going to take then subtract. Negative is underwater, 2.1. Then I can add the opposite, and I've got 10.8 feet for the height of the boat, which you can also see there. If it's 8.7 and 2.1, then it's 10.8. All right. And then I want to find the height of the boat and the height of the trailer. And these are both positive numbers, so I can do 10.8 and 1.3, line up my decimals, 8, 9, 10, 11, 2, 1. And it's 12.1 feet. And since 12.1 is greater than 11 feet, 8 inches, it won't fit. All right. Hopefully that was all okay. The you try is a little bit tricky. Remember, you're going to do some math here, and it tells you that the clearance is 12 feet 1 inch. But this is not 1 inch. Let's just kind of do this one together, kind of thinking through that. This looks like it would fit, right? 12 feet 1 inch and 12.1. But this 0.1 is not 1 inch. This is 1/10 of a foot. Let's see, so our boat plus trailer equals 12 feet plus 1/10 of a foot, which is greater? Is 1/10 or an inch is a sixth? Sorry, yes, this is 1/10 of a foot, and an inch is 1/12 of a foot. Does that make sense? 1 inch is 1/12 of a foot, and this amount, this 0.1, is 1/10 of a foot. Which one of those is bigger? This one's bigger. 1/10 is bigger than 1/12. So here's your clearance, 12 feet 1 inch, but your boat still won't fit. It's close, very close. Maybe you'll just scrape off the top of your boat. I thought that was a pretty tricky you try.